Welcome everyone. Welcome to this webinar on getting started with the Gradle Kotlin DSL. I'm Paul, this is Rodrigo, and we are the Kotlin DSL team at Gradle. We'll get started by asking you a couple of questions to get to know the audience. The first one is about how you are using Gradle. You'll see the question displayed, and we'll wait just a bit to get some answers. So,
interesting.
Yeah.
Lots of Groovy DSL users in the house.
A bit more than a half so far, and something like 10% not using Gradle yet. That's interesting too. And 15% already using the Kotlin DSL, and 20% mixing both languages. That's good. Very interesting. Thank you. The second question is, what is your primary programming language? So you'll see a few options. We only had 5 slots, so please, if your primary language isn't in the options, send us the details as a questions in the question box. Looks like it's mostly Java,
Nice.
as expected. Well, a bit more than half. Kotlin going up. Yeah, so 35% Kotlin almost. A bit of Groovy, a bit of native, and some others. Good, thank you. Before going to the Gradle Kotlin DSL itself, we'll look a bit about what's Gradle. And we'll start with Gradle purpose. So it's a build tool and automation tool. It's JVM based, meaning it runs on the JVM. It's implemented in Java, and it's open source. Licensed with the Apache license. So we said it's an automation tool before a build tool because it's agnostic of the target ecosystem, meaning you can build for the JVM ecosystem, for many JVM languages, Java, of course, Groovy, Kotlin, Scala. There are plugins for others like Clojure and so on. The native ecosystem is quite well supported too, and of course Android, which is a large user base. But it's not limited to that. You can automate pretty everything, and we have community plugins again for Python, Go. There are some for Rust, and ASCII Doctor, and JavaScript. And this very presentation is actually built with Gradle using ASCII Doctor. And the company behind Gradle also edit a commercial product named Gradle Enterprise that is all about developer productivity, and it's mostly split into 2 feature sets. One is build scans, which are permanent records of what happened during a build, so you can collect them and very easily share them with your colleagues to troubleshoot issues and so on. And the build cache is mostly about reusing work across your company. And it's not only support the Gradle build tool, but also the Maven build tool. So we saw that Gradle is agnostic of the ecosystem, so we'll run another question to get to know you. And the question is what type of application you are building. So again, only 5 slots, so please send us details. Oh, it's like web services competing with Android applications mostly. Okay, so half of the people building web services makes sense today. And mobile apps, mostly Android, again, it makes sense given the official support is made with Gradle. Yeah, and 10% on desktop application, interesting. Good, thank you. So, Now we'll go in more details into the Kotlin DSL, starting by creating a build using it from scratch, and then customizing it, configuring things, and then like growing it, and then how like identifying patterns to organize the build logic. And then we'll talk a bit about good practices to author plugins and DSLs.
Before we go into that, before we start with the Kotlin DSL, it's interesting to get to know a bit more about the Gradle basics. We talked about how Gradle, right, is this automation tool that can automate the execution of work. And that mainly happens through the automation of tasks, right? Tasks are the main thing you'll be dealing with or executing in your Gradle build. So you'll be configuring tasks and registering tasks, creating tasks. That's how a Gradle build works, right? Those tasks can be configured using Groovy DSL scripts. As we saw, we have a lot of Groovy users today. But now we also have the Kotlin DSL, right? Which is using the Kotlin language as a base for configuring those tasks. In the end, right, we can see that both DSLs are this like sugar on top of a rich Java API for automation, right, for automating tasks. So we have the Groovy DSL, the Kotlin DSL built on top of this rich Java API for automation of work, right? And what Gradle actually does in the end, right, besides automating all that work and tasks, is to make sure it avoids work. It does the dependency management resolution and everything else that goes with it, like downloading artifacts, etc. And the main way we reuse and like package functionality in Gradle is by packaging those tasks and their configuration as plugins, right? So that's how you mainly interact with Gradle, by using plugins, right? From either the plugin portal or from repositories or from your local disk, right? That's how you use Gradle. So this, just to give, you know, a bit, right, of introduction in what a Gradle build looks like. It's a Java library or a build script written using the Kotlin DSL for a Java library, right? So we can see we apply plugins, we can configure, you know, how that plugin will work, and we can see how we can add some dependencies to control how our library will be built. But we can also build a native app, right? So it's not only about Java. So as we said, Gradle is agnostic of the platform. So here we see a native app written in C++, and then we can actually go and configure, you know, the tool chains, like you're using GCC, or maybe you're using Visual Studio on Windows, and that's how you would interact with that plugin, right?
All right, so let's get into practical things. So we'll get started by creating a Gradle Kotlin DSL enabled build from scratch, and you can do that in two ways. The first one is, like, if you already have Gradle locally installed on your machine, you can use this init task. It's a task that provides an interactive workflow that suggests a set of templates builds. Here we selected the Kotlin application build for the sake of the example, and of course the Kotlin DSL for the build scripts, a name, and that's it. It's that simple. So the second way you could use to create a Kotlin DSL build without having Gradle locally installed is from a web UI with this Gradle initializer project, which is basically driving the Gradle init task. It's exactly the same thing, but you don't need Gradle installed. So we'll do the same, like choose a Kotlin application, choose the Kotlin DSL for scripts, set a project name and package name for the source code, and click generate, and you get a zip file that contains the same thing that Gradle init creates. This can be automated with the command line if that's your thing. But in both cases, what we get is exactly the same, and that's the file tree you currently see. The first thing to notice here is the Gradle script file extensions. It says .gradle.kts, where KTS stands for Kotlin script, and that's basically how you opt in to the Gradle Kotlin DSL. Like, .gradle files will use the Groovy DSL, and .gradle KTS file will use the Kotlin DSL. And the first file we see is the setting script. The setting script controls the settings for the whole build. And the most common thing you control there is the project structure. Here we have only one project, and we just set its name, and that's it. There are other global build configuration you can do in a setting script, like configuring the build cache, configuring how build plugins are resolved, etc. The second file, it's the build.gradle.kts, is the root project build script, so it's the build script for the root project. And we'll have a quick look at it. So we see here that we apply plugins, and if we just read that, it says we apply the plugin with the Kotlin JVM ID and the version, and the application plugin. We're basically configuring Kotlin JVM application as we selected with the Gradle init. And then it set up a repository where to fetch dependencies, and then declare some implementation and test implementation dependencies. If you want to know more about this important topic, please see the dependency management fundamental webinar that was done recently. And the last block is setting up our application main entry point. And then there are a few files that are very important, like the Gradle W, Gradle W.bat, and the Gradle folder with the wrapper files, the jar and the properties. The wrapper is a way for a build to declare and specify the version of Gradle it uses. So it's a way to lock the version of Gradle you use to build that build. And the script, like the Gradle W and Gradle W.bat scripts, they will automatically download the declared distribution. It means that it makes it very easy for people to get the build up and running, either on their developer machine or on CI. Just like fetch the sources from somewhere, run the script, it will download Gradle and run the build. There's only one requirement, which is you need to have a JVM installed to bootstrap the whole build. And then we see, of course, an application without sources wouldn't make sense. So we see the sources for the application and its tests, and we see it follows the standard layout. And then we'll get to run that build, but first from the command line.
Running the build, right, is as easy as using the Gradle script that is provided by the init plugin, right? So you really want to use the Gradle script to make sure you're using the Gradle version that you selected during the setup process, right? So as I said, right, you run tasks with Gradle, right? That's your main interface with Gradle. So here we're gonna run our application, right? So I'm telling Gradle to run my application. And this is a very simple application, right? So it says hello world, and that's how you run it. The next thing, right, you might want to do with the build, right, is to actually work with it using an IDE.
Yeah, speaking of which, we'll do another quick poll about what IDE you are using before going further.
Mm-hmm.
All right, so JetBrains IDEs are the clear winners, it seems.
Yeah.
Some Eclipse and some Apache NetBeans users. Not much, but still.
I guess Eclipse users will be happy to know, right, that JetBrains is now committed to improving the Kotlin experience in Eclipse, including, right, the
Gradle Kotlin DSL. Yes, like the issue went to in progress recently.
Yeah, nice. After you executed your build, right, you want to actually import it into an IDE. So here I'm using IntelliJ, like the community edition, the free community edition, the latest stable version, 2019 one. Mm-hmm. And I basically selected the folder we just saw, right, we just generated, and I'm saying import, I'm gonna open it. I want to select the Gradle model, right? And I'm gonna run it with the Java 11 version. We can use all the default settings, right? And then press finish.
Your window will be fine.
Yeah. So then, as we can see here, right, we get basically the same structure, right? It is the same structure we just saw, right? We have our script here with syntax highlighting. Of course, the first time you open the script, you might have to wait just a bit as dependencies are resolved, downloaded, and the highlighting works. Right? Yeah, that was fast. Talking about running the build again, right? You have a few options here with IntelliJ in particular. We have our faithful terminal, right? We can just, again, interact with Gradle using the terminal here, right? Just to run a different task, I'm going to run the check task that executes your tests, and maybe you have like code quality tasks that will, you know, inspect your source code. So that's a way to do it. We can also use, you know, there's a very nice feature in IntelliJ that I like it a lot, is the run anything, and it actually supports Gradle, right? So you can just say Gradle and run again, and then there we have it, right? A very interesting thing, right, is that Gradle is actually now the default runner. When you import a Gradle project and you want to say execute a test, so I'm gonna go to my app test, right? And if I choose to run the test now, IntelliJ will actually use the Gradle test task to run that build, right? So again, if you have any sort of deep dependencies for your task, you have code quality, other sort of inspections, you have code generation maybe in the mix, that will all be honored now by IntelliJ, which is pretty cool.
Right, so now we have first build and we want to customize it, right? That's why we're here. So we're looking at this build, the same example Kotlin JVM application. And now let's say we want to change the way this application is run. For example, we want to limit the amount of memory given to the Java process to only 4 megabytes. That should be plenty enough for
anyone.
For a hello world.
Okay.
Well, that should be plenty enough. It's much better than half of your memory, which is the default. So, a quarter of your memory, which is the default. So with the JVM, we can achieve that by using the -xmx command line argument. So we should be able to tell the application plugin how to do just that. So let's take a closer look at this application block we have in the configuration. This application block is what we call an extension configuration block. Because plugins, like the application plugin that is applied here, they contribute extensions to the DSL. They extend the DSL to add more language elements to your scripts. And this one was contributed by the application plugin. So yeah, we should be able to configure it. And what we want to configure here is the arguments. So let's ask the IDE if there is something. Yes, there is something named the application default JVM arg. That's exactly what we want to set. And I saw it's an iterable of string. This was in the documentation showing up, right? Yes. So a list of string will do. Yeah. And we want to set like dash, capital X, mx, for little m. And that should do it. So here the IDE provided with us a lot of help. And that's thanks to the type safety of the Kotlin language.
Yeah, and at this point, right, we actually changed the configuration, right? We changed the way our application is supposed to run. So then we actually have to import those changes so the IDE can actually run it in the proper way, right? So I just go ahead and do it. So at this point, you should be able to just run it, I guess.
Yeah, let's run it and let's check that it had an effect and that the new configuration is taken into account. And let's run with -y, which means information, so we get a bit more logs, and we should get the command line.
So if we search for
XMX?
XMX, I guess.
Yeah, good, starting process, and that's it. So it did work. Yeah, and we could also look at the distribution, like what about when I distribute this application, will these settings also be taken into account? So
I guess I have to build the application first.
Yeah, like run Gradle assemble. Good, and now we should be able to look at the archives in distributions, like the zip, and then in bin, the script. Mm-hmm. And then here we should be able to find the same.
Something about 4 megabytes.
Okay. So yeah, that's it. We configured the application plugin, and it has the expected effect. The IDE helped us, and we use this application block contributed by the application plugin.
Mm-hmm. Right, as we saw, we could run it in both ways. And another thing, right, we might want to do with our application, right, is to make sure, for instance, that we don't introduce unintended warnings into the code base, right? Warnings can be actually signs of bugs in the code base, right? So we want to make sure we always fail the application or fail the compilation of the application when any warnings are introduced, right? And the Kotlin compiler is actually able to do just that, right? It can actually inspect your code and make sure no warnings are there, right? So we should be able to go and configure the Kotlin compiler.
And like we said, Gradle do actual work by running tasks, right?
Yeah.
So there must be a compilation task.
To configure tasks, right, the tasks are also available in the Kotlin DSL, right, in this task block. So here we can actually configure any of the tasks that are now available in my build, right? So if it's something about compile, I should be able to then, right, inspect such tasks. We can see there's a few of them, right? There's the compile Kotlin task, there's a compile Java task, there's a compile test Java, compile test Kotlin, right? They're all existing tasks, right, as the documentation says. I'm gonna do the inspection. I want to do the inspection of warnings just for my production sources, and that's the compile Kotlin task. If warnings are introduced in the test, I'm not as concerned, so I'm gonna do this for this task, right? And again, the way we configure a task is by entering the task block, this task configuration block, just like we did for extensions, right? We want to change the way the compiler works, so we want to change the compiler options, right? So we should be able to see something about options. And there we go. So this is the block that lets us configure the Kotlin options. And there should be something here about
warnings.
Warnings, maybe, yeah, let's start with just that, warnings. And
that's
there should
exactly
be
what we want.
So it's just a Boolean flag. I'll go there and just say, well, all warnings as errors, right? And again, since I changed, right, the configuration of the compiler, I should go ahead and let IntelliJ know about those changes so we can execute the build in the right way. Okay, so now we should be able to just run the application again, right? So just to make sure everything still works, right? Yeah, it still works.
We should also check that it actually fails when we introduce a warning.
We should. We definitely should, right? So let's do that. So let's go to our app and maybe just introduce a random warning here. I'm gonna just duplicate the line, right? And as you can see, the IDE already flags that as an error, right? You can see it's unreachable code. So again, if I run in the console, I should see that fail. And we do see it fail, right? And it's the same warning we saw before.
Yeah. And it says warnings found and warning as error was specified.
So let's just fix that warning. And maybe run the application again. And there we go.
So we learned a few things so far. We can change the configuration and the behavior of the build by configuring extensions and tasks. So tasks are units of work, like we said, that's how Gradle model work. And you can configure specific tasks directly for like we did to configure the Kotlin compiler. And you can also configure extensions. And extensions are more like high-level constructs. Like the application plugin has these application extensions where we set the JVM arguments, and we saw that it influenced several tasks, like the run task and the task to create the application scripts and so on. Both are contributed by plugins. So plugins basically enhance the Gradle DSL through extensions and tasks. And you use scripts and DSLs to configure that. And going a bit further, so our build was really simple. It's just a single project. But in reality, and most people don't do so simple builds. And even like Android developers, when you start to build, like if you use Android Studio and create a new build, you will already have a modularized build because there is a sub-project. So let's take our sample application and split it into two. And we want to have a core library and then a UI, which will be the command line application. So we don't, like, we keep our Hello World example, but we did split it. And that involves a bit of manual work, but we'll show you the results, and it's very simple. So instead of having, like, the first thing we do is use the settings file, the settings script. Like we saw, its purpose is to control like the structure of the build. So we say we want to include two projects, one named core and one named app. And it means we have two subfolders, the core subfolder and the app subfolder. And what we did as a first step is we just duplicated, like we have 2 build scripts now for the sub-projects. And we basically duplicated all the configuration logic, like the repositories declaration, the dependencies, the task configuration. So it's not ideal at all, but it works.
It works.
It's a good first step.
So we can actually see that it works, and it's the exact same behavior as before, right? So I'm gonna run the task in quiet mode, so we only see the output of the actual application, right? And it's the same app.
Yeah. So the first thing, so we will now go into the process of making this a bit better. Because of course, duplicated build logic, it's like production code. You don't want to repeat yourself. And if you need to change something, you don't want to have to change it at all the places you duplicated things. So let's factor all this logic. So we now have a build with a project structure where we have the root project. Can we show the root project build script? It's empty, right? Yes. So we have this root project, and then we have 2 children, the app and the core. Gradle evaluates your build script following the hierarchy. So it evaluates first the root and then the sub-projects. And it's important to keep in mind to know how you can articulate your build logic. In this example, if we want to dedupe some things, it will only be about like pulling things up from the sub-project to the root project. Right. And we'll start with the beginning of the script. So both the core and the app script, they declare that they use the Kotlin JVM plugin with version 1.3.21 here. But we don't want to duplicate that. So we want to move that up to the root project. So let's do that. Good. All right, so now we change this script, and IntelliJ is telling us there are new script dependencies available. And that's because when you request a plugin, it will download it, and it will make it available to the class path of this script. And so the ID editor context must be refreshed. So you can say apply dependencies. And it says that the build configuration failed. Let's follow his advice.
Yeah, let's
and run Gradle task to know
we use the run anything.
What's happening.
Fun of it, yeah.
So it says that the plugin request for the Kotlin JVM plugin here must not include a version. Of course, we moved that up into the root project, and the root project is now the one who is specifying the version. Yeah. Meaning we should remove it from the 2 sub-project scripts.
Yes, let's do that. Here and remove it, go there and remove it. And I guess now we should be able to run the build. Yeah, it's import.
Let's go back to the root build script. So now this one is the only one having the version declared.
But this project is in fact not a Kotlin project, right? So it doesn't make sense to actually
apply the Kotlin plugin to it. Right. So we should specify that we only want to declare that we will use this plugin, this version, but we won't apply it to this root project. And that's done using
apply.
False. Good.
We're good to go. Yeah. I guess we could again run the application at this point just to see everything still works. Yeah.
Good. Okay, so one step at a time. We extracted, like we moved up the Kotlin JVM plugin version, but we have more things duplicated. Still the plugins block is duplicated in between the two things. So the root project is now like declaring what version of plugin we do, but we could also declare that all of our sub-projects, they use the same plugin.
Right. That sounds like a good step. So I guess we take the ID of the project.
We'll need the ID of the plugin, of course. And then we want to configure sub-projects. So this is named cross-configuring projects. Like from one project, we configure others. And we do that, again, following the evaluation hierarchy of scripts. So what we want to do here is apply. So we use the apply function, and we apply the plugin, the Kotlin JVM plugin, to all sub-projects.
And now we could actually remove the plugins from every sub-project.
Yeah. Let's remove duplication. So here we will only remove the Kotlin JVM plugin because we want to keep the application plugin here. Wait a sec. So IntelliJ is keeping asking us about, like when we make change to scripts, keep asking us about applying dependencies when we edit. We could enable auto reload here because it's cheap. It's like much cheaper than re-importing the whole project. And we actually want the dependencies updated.
Okay,
so let's enable it. Yeah.
Okay, you're the boss.
Did you remove the plugins in the other project yet?
No.
No, let's do that.
So we can remove everything at this point, right?
Yeah.
The plugins block at least.
Good. So next, it's the, of course, it needs to reload the dependencies.
We could also import changes because we changed the structure.
Right.
And we still, so let's do that.
Yeah. Okay. Good. So both projects also you have the repositories. So let's move it up.
Let's move it up. Go here.
Yes. Good.
And now we go to app and do the same. Remove it from here.
And the dependencies are mostly the same. Like the only difference between our core library and our app is that one depends on the other.
Right.
But the three other dependencies, we could pull them up.
Right, which is basically the dependencies block from the core module, right? So we can just go there and move it. So again, oops.
Good. So here, something is red in the IDE, and it says that the configuration failed. And what it says is that it couldn't reference the implementation word. So here we are in a sub-project block, and we are cross-configuring sub-projects. But the Kotlin DSL didn't have a chance to know that those configurations actually exist and to provide type-safe accessors.
Yeah, because the plugin is not really applied to the root project. And this is still the root project script. So even though we are saying that we are configuring a sub-project, right? The Kotlin DSL gets loaded in the context of the root project. So that's the model, right? It inspects, I guess. Yeah. So that's how we can...
Yeah, and another way to put it is that the Kotlin DSL can provide like type-safe static accessors to dynamic elements only if your plugin, like applied plugin dependencies are specified declaratively using the plugins block or from a project above in the hierarchy because of the evaluation order.
Right.
So here we don't have access to those type safe accessors. So what we need here, like implementation. Implementation is a configuration, a Gradle configuration, to which we want to add this dependency. And configuration can be addressed by name, right? And with the Kotlin DSL, the way you do that is by using a string for the name.
Yeah. So that's one way to do it, right?
And there's another way. And we'll show it with this example because we have two instances of this reference to this dynamic thing. And we don't want to have a typo in the string. Yeah. So we want to tell the Kotlin DSL to bring into scope a reference to that existing configuration. So that's the two ways to do that.
Yeah. And with that now in place, we can actually import the project again. So the configuration runs.
Yeah.
I'm not sure I actually deleted all the dependencies I should have.
I guess you didn't here. Yes. Okay, so this block should be only like the app depending on core.
Right. And now on the core, yeah, we moved everything. So now we could go back and actually, well, let's import one more time because I did do one change. And now we should be able to again run the application, and the fact should be exactly the same. Let's run the application. Right?
Yes. And there is still one more duplication.
In fact, there is one more duplication.
Which is the Kotlin compiler configuration we did earlier. Both projects have this task compile Kotlin, Kotlin option block. And we should move that up too.
Yeah, so at this point, I guess I could take the whole task
the
block
core script
and move it.
as nothing special. So,
so let's
put that here. Yeah. And now again, we see some red code and configuration failing. And it's the same ID. It says that the compile Kotlin name cannot be resolved. And it's the same ID, like the Kotlin DSL didn't have a chance to provide you with a type safe static accessor here. Yes. But fear not. Like the Gradle DSLs and API provide everything you need to do that properly. So what we want to do here is we want to configure a task, right? Named compile Kotlin. And this gives us a block to configure a task with the generic task type. But it doesn't have the Kotlin option, of course.
Right.
So what we want to configure is a task named compile Kotlin of the Kotlin compile type. And we get the completion in the ID, and then all good.
And I guess that's, well, I still have to delete the same block from app, right?
Yes.
And
now this script is only about the specificities of this sub-project.
Nice.
And we have extracted all the duplicated logic up
to
the root project.
This would be a good time to import.
Yeah, and run it.
Should still
just
run.
to make sure.
Yeah. So let's run the app.
Good. Okay, so let's take a quick step back. We learned a few things doing that. We learned that the project evaluation order follows a hierarchy of projects. That's a key thing to keep in mind. We also learned that the script class path is inherited along this same hierarchy. Like we require the Kotlin JVM script in the root project, and then the types for it were available. And
Kotlin JVM plugin?
Yeah. Yes. And we also learned that cross-configuring requires dynamic references. and we learned how to do it. Well, in other words, that type-safe accessors are not always available. There are cases they are not. And you can refer to the Kotlin DSL primer in the Gradle user manual. And it details all the cases where the type-safe accessors are available or not.
Another thing, right, that you might bump into as you are, configuring your build, right, is that you might want to reuse some pre-existing logic, some pre-existing conventions, right, from your company, maybe another team, or there's like a build team, right, in the company that wants to standardize on some sort of conventions, right, like maybe the licensing of the projects, right, they all should be of a certain way, or they should be declared, right. So let's say we have this standard licensing plugin, right, or script that is distributed for all the teams in my company, and now I want to use that in my build. The only catch, right, is that maybe this script is actually a Groovy script, right, and we want to use that Groovy script in the Kotlin DSL, right? So here we have a very simple Groovy script, a Gradle Groovy script, right? That defines a licensing model, right? With like 2 licenses, right? The only 2 true licenses, the GPL and the LGPL, right? By default, we assume every project is licensed under the LGPL, right? And that's how the plugin works. The plugin also lets, right, projects to declare their licensing options via an extension.
So it creates an extension contributing to the DSL.
Exactly. And for the purpose of this demo, we removed all the complex validation of license and all that, right? And it simply prints which license was chosen, right, for by a particular project. Right? So that's the script we want to apply. In our example, right, the script is actually living inside our code base, but it could be coming from the network, anywhere reachable, right, from your build. So this is still the same build, right? We're just extending, so we can see this is just like we had before. We have the repositories, the plugins, and the configurations. So we want to apply this
to all sub-projects.
To all sub-projects, I guess. So again, right, we use this verb apply, so there must be something about applying here, right? And this time, we actually want to apply a script from a certain location, right?
Yeah, it's not, we don't have a plugin ID, we only have a location.
Yeah, it's just a file based off my root project, right? So we can just go and find it, right? Starting with the root project, right? There's a file, and it should be such file, right? And we can import changes.
That's it.
To make sure, and we applied. So let's run it, right? I'm gonna use the faithful terminal for this one. Oops. I don't know what's going on, so I'm gonna use this one. So as we run the script, right, when it actually configures my build, we can see that the plugin, the script plugin was actually applied, right? And it configured my app to use the LGPL license and the core project, the LGPL. Turns out I don't actually want to license my app under the GPL because it's an app, right? I want to license under the terms of the GPL. So I should be able now to go to the particular build script that controls the settings for that project and change it, right? So let's do that. So again, I'm gonna go to the app build script, right?
And so we saw that the Groovy script was contributing an extension to the DSL. It was named licensing.
So there should be something about licensing.
Right.
And indeed there is. So we can go and configure the license, I guess.
Looks like we cannot. And it looks like it's typed any.
Right, right. We can actually look at the docs and see what's going on here, right? So, because, right, this is a Groovy script that was applied to a project, right? And it defines types, right, that should be visible here, but they actually are not, as the Kotlin DSL says here, right? The type of this extension licensing is actually not accessible here because the type is simply not available. The type is not available because of the way the Gradle isolates, right, the class path of applied scripts. So even though that type does indeed exist, right, in that class loader, in that class path, it's not available to my script, right? So we're stuck, I guess.
Or we could use some reflection.
We could use some reflection. Or we could use the Kotlin DSL. The Kotlin DSL actually has a few interoperability helpers, right? The one we want to use here is the Groovy Builder interoperability helper. What this helper lets you do is basically opt into this dynamic semantics of Groovy, right? And actually use a bit of dynamic logic inside our statically typed world, right? So as we saw, right, in the licensing script, we have the licensing extension, and it provides this license function that lets me actually pass a license, right? So if I go back to my script, I should be able to call this method by using the dynamic invocation syntax. The thing is, we saw the function actually takes an enum, and again, that enum lives, right, in this class loader, right, in this class path. We don't have access to non-reachable class path. So what we can do at this point is pass a string, because Groovy is happy enough to simply go and convert, right, a script to an enum. So let's do that. So I want to use the GPL.
Right.
And this should work at this point, right? So I'm going to run the app again, right? Maybe I import changes just to make sure everything's still good, right? And let's run it. And now I should see that the app is actually licensed under the GPL.
Good.
Right? So maybe now we step back a bit and see what we learned. So we learned that, in fact, you can just mix Kotlin and Groovy scripts in the same build, right? Both are equally supported. They basically will be supported, right? And yeah, different strokes for different folks, I guess, right? They can just work together.
Or the best of both worlds.
Yes. So we also learned that when the types are not available, right, for whatever reason, in this case it was because they were coming from this class path or this class loader with this class path that was isolated from my build script, right? We can use with Groovy Builder. And we have other facilities in the Kotlin DSL, right? You should refer to the Kotlin DSL primer in the user manual. And there we describe all the different ways you can actually interpret with Groovy, right, from Kotlin, right?
All right, so now that we saw like several aspects of customizing a build, we look at some patterns for organizing the build logic, because so we saw cross configuration first, like moving things up in the project hierarchy to remove duplication and so on. But the build we use as an example is really simple, and with time and complexity you will add more functionality to your build, and the build script logic can get unwieldy and gets into this unmanageable state with this 1,000 line root project build script. You don't want to go there. So we'll see how two patterns help with dealing with this growing complexity. The first one is build source, and the second one will be about sharing build logic between builds. So, build source. Build source, it's a convention supported by Gradle that allows you to extract build logic further up, like before, even before the root project, into a separate build. But it's a separate build that is tied to your outer build. So it's for going further, organizing your build logic inside your build. Okay, so here we can see the layout. So we see the same build again. Like if we start from the bottom, we have our setting script, our build script, the Gradle wrapper, our core module, our app module, and then we have this thing, the build source. We can already spot that it's a separate build because it has a settings script.
Yes.
And it's a build, so it has a build script and sources.
That means that it could also actually have a rich, project structure of its own, right?
Right.
So
yeah.
It's a build.
Yeah, it's a build. And it builds things in source, SRC, main, Java, Kotlin, Groovy, anything. Meaning you will have the more tooling than just scripts, because you will be able to organize your code in packages, create types, use the language,
right.
have tests, and so on. So let's do that. Let's move the build logic we have to build source. So here we skipped a few steps to manual step creating directories, but it was basically creating the directories we saw at the previous slide. And so the build script you can see here is the one for the build source project, and it's applying the Kotlin DSL plugin. And this plugin is about bringing the features of the Gradle Kotlin DSL to Kotlin source set, so to SRC main Kotlin. Mm-hmm. So build source is a build that will build the SRC main Kotlin sources, but because we use the Kotlin DSL plugin, it gets not only the Kotlin language features, but also the Gradle Kotlin DSL features. Mm-hmm. And we'll leverage that. Here we already moved, the first thing we did when we moved things up in the root project is moving the declaration of the Kotlin JVM plugin version. Mm-hmm. And here we extracted it further up, declared the dependency as a regular dependency, because actually build source is like any other JVM project building an artifact, a jar. Mm-hmm. And this is that jar that will go into the class path of your root project and all the child project scripts. Mm-hmm. In build logic, not in the production, it's only for build logic.
Yeah. So in fact, right, the root script is basically the same as we had before in the previous step, except for deplugging, right?
Except for declaring the Kotlin JVM plugin version.
Yeah.
All right. So let's imagine our root build script is starting to get big with lots of logic and so on, and we want to make it more manageable. Mm-hmm. So we said that in Gradle you package chunks of functionality as plugins.
We did say that.
So that's exactly what we'll do. We'll extract this build logic as a Gradle plugin into build source. Mm-hmm. So we'll do that by creating a Gradle Kotlin DSL script into SRC main Kotlin. Let's say Kotlin-conventions, because we will capture our Kotlin conventions, like the dependencies and the configuration of the Kotlin compiler. Good. So we can create a Gradle KTS script in a Kotlin source set thanks to the Kotlin DSL plugin we applied to the build script. Yeah, and let's start moving things.
Just the plugin to start with?
Yeah.
Let's just move that. Or in fact, we can basically say we're going to now apply the Kotlin conventions plugin.
Yes. Right. Yeah. So one thing to note here is that the plugin ID is derived from the name of the script file in the Kotlin source set here.
Right. Yeah.
So here it's in the default package, so it's just Kotlin-convention, but packages are taken into account. Like if your script has a package declaration, yeah, then it will be namespaced basically. But let's keep it simple. And so here what we want then is to apply, like request the Kotlin JVM plugin.
There's actually a shortcut for that, right, in the Kotlin DSL that we could use at this point, I guess.
Sure.
So the Kotlin DSL also makes easier to work with Kotlin, right? And so you can actually use the Kotlin plugin spec builder to apply any Kotlin plugin, right?
Like the JVM, the Android one, the JavaScript one, the native one.
Yeah. So as the documentation says, you can visit the plugin portal to see which plugins are available here.
And we don't need a version, right? Because it's already declared in the build source build script. So that should be it.
Yeah, so this is exactly the same as doing this, just in case you were wondering. Just in case you were wondering. It is exactly the same, except that it's a bit less characters to type and to read. So.
And again, IntelliJ is asking us to apply dependencies. So earlier we clicked on enable auto reload. This setting is per imported build. And here we are working on separate ones for each step. So that explains it. But we want the new dependencies.
Okay, so I'm going to enable that.
So let's just check if it works. So what we did is we replaced applying the Kotlin JVM plugin by applying our conventional plugin. That itself applies the Kotlin JVM plugin. Small steps.
So it's compiling. Let's apply.
Yes.
Let's apply. Yeah. So some state got stale there, but we can actually see everything still works, or it should work if it's to run. In fact,
that's live coding. Yes. All right. So now let's get to the meaty part and actually extract the build logic, like dependencies and the Kotlin compiler configuration.
Right. So we could just take everything.
That's our Kotlin convention.
Yeah. Let's do that. So we can take just that, go to the Kotlin conventions plugin.
So did you see the editor ended up in a good state in the end?
Yeah,
just took a bit of time.
Yeah. Okay.
All good.
It just works.
Great. But actually there is opportunity for simplification here.
Just a second, let's just see if it actually works. Let's actually, something going on there.
Yeah, it's still loading.
We can actually run the build in the meantime.
It's good.
And it's all good, right? So it still runs as expected. So we might wonder, right, if the configurations, for instance, that we apply to the compile task are actually being taken into account, right? Just, let's see. So if I go to the app again, right, and introduce a warning, say, right, we should still get the same guarantees that we had before, right? And in fact, we do.
Good.
So I'm gonna fix that, run again, just to be in a good state. Yes, it works. And you were saying?
I was saying that the Kotlin, our new Kotlin convention plugin written as a script could be simplified. Because when we were doing cross configuration, we didn't have the type safe static accessors the Kotlin DSL can provide. But here we should have them. Because we have the plugins block declaratively requesting the plugin. So we shouldn't need.
Yeah, the Kotlin DSL should be able to figure out, right, what is that the Kotlin JVM plugin is providing, right, to the Gradle model, right? And so like this implementation configuration should just be there, right? And the test implementation should just be there, right?
So it means we could replace this or like name it, dynamic reference to compile Kotlin, type it.
Oh yeah, it should be there, right?
You just said. Nice.
And at this point, we can actually just organize imports because the Kotlin compile task is no longer used, right? And we are back to a very self-contained, simple
declarative
conventions plugin, right?
Nice.
And let's go back to the root script, see if everything still is fine.
Yeah.
It keeps saying that, but in fact, we know that it can actually run, right? It will just take a bit of time the first time as everything warms up. Let's import changes. Maybe that will satisfy the IDE.
It'll be fine eventually. Okay, good. So again, let's take a quick step back. So we learned that build source, the build is a conventional build for build logic in Gradle. And it allows you to extract common build logic to your whole build inside a single place where you can benefit from source sets, meaning your whole language tools, like declaring interfaces, types, and so on. And also the Kotlin DSL features, like we saw we can put Gradle Kotlin DSL script there and benefit from its goodness with the plugins block and type safe accessors. And this script get exposed as plugin with their ID derived from the name. We can just apply them. Again, this is all documented in the Kotlin DSL primer in the usual manual, so go read it.
Another interesting scenario, right? So is sharing build logic not only, right, inside a single build, but across different builds, right, in an organization, right? Maybe you have like, it doesn't really matter if it's a monorepo or like multi-repo, but let's say a monorepo with multiple builds, right? And you want to make sure you have the same set of conventions across all those builds, right? So you want to share.
You don't want to duplicate your build logic again.
You don't want to duplicate your build logic. And you might, for whatever reason, you might not want to make all those projects or all those builds part of a single build, right? And have like a multi-project Gradle build, right? So you actually want to keep them, all the builds separated for the different parts for different reasons.
For different reasons. It could be because you release them at a different pace or whatever.
So the solution to that, right, is to go like one level up, right? So another level up, right? So basically, I guess as they say, right, any problem in computer science can be solved by another level of indirection. And I guess sharing build logic can be solved by just going one level up, just go one level up. And here we are going one level up. So in this structure, we basically have the same structure we had before, except that now what we had here as build source has been extracted up as a sibling of my build, right? And I just renamed it build logic. It could be any name because it's a build, right? It's a Gradle build. You can control the name, you can control its version. Now it can be versioned separately, even from your project, right? And that's really as simple as that, with a bit of configuration of the connections between those builds, and that's all you have.
Naturally, you have to declare that connection somehow.
Yeah, so let's see how that actually works, right? So here we have this extraction, right, already imported into my IDE. And what I did, right, I simply imported the same app as I had before. But now, because I actually declare in my settings Gradle file that I'm including a build, right? There is a sibling. Right?
So that's the Gradle composite builds.
Yeah, we're talking about Gradle composite builds here. Yeah, so you should also read the docs because this is really, really great. And what you get automatically also from IDEA, right, is that project gets imported, right? So you can still like use the same tricks, you can navigate, right, to your build logic. So the Kotlin conventions plugin still there, same logic, right? Eventually it will light up.
You will.
And so the first thing you want to do, right, when you move build source up, is to include the build, right? And then you have to also set, right, because we want to include that build as build logic into my build. What I'm doing here is saying that for my root project in this consuming build, right, I want all my build scripts, right, to have that build logic build in their class path, right? And
so the jar built by that other build will end up in the class path of my root project and hence be available to all my sub-project build scripts.
Exactly.
So everybody will be able to see it, and I could use it from any build script in
any build script. We have to, of course, so the decision of repositories where to download, for instance, the Kotlin Gradle plugin, right, belongs to the consuming build, because we might have one build might be using one repository, another build a different repository for whatever reasons, whatever conventions, right? So this is basically so the Kotlin Gradle plugin can be found, right? It's not about finding the build logic. Finding the build logic is enough to just make this connection, right? I include the build and I declare a dependency. But here's the one catch, right? So I'm using these coordinates to connect these two builds, right? I'm saying, oh, this is the webinar group, the build logic name, and the 1.0 version, right? I'm using the
like group name version.
Group name version
like
coordinates.
Regular dependency coordinates.
Mm-hmm. So that means that my build logic build actually has to declare that.
Sure.
And the way we make sure, first we declare the name, right? We declare the name of the build in the root script and build logic. And in the root build script for my build logic, oops.
I think it's the first one.
Yeah. I actually add a group and add a version. And the rest is basically or exactly the same as before.
Like as before in build source.
In build source.
Yeah.
Exactly. And that's it, right? So we should be able, again, to run the build and see the exact same effect.
Okay. So here's the idea is that we had our build with some build logic inside that was in build source, but it was like constrained to that build. And then we moved it as a separate build, like a sibling folder.
Yes.
We included, but it means we could have like lots of build, like, I don't know, 500 apps that include the same guy providing build logic.
Yes. That's exactly right.
Good. And the Kotlin DSL works all the way. Like you can navigate from your build logic types, from your build script, you can navigate to the types.
Yeah.
from the build logic, and so on. Okay, so we talked about how to organize the build logic, but the build logic is mainly comprised of plugins, right? So we'll talk a bit about how to author those plugins. And of the challenges that sharing them with a wider audience, like writing a plugin for people in your company to use, other teams in your company, or open source plugins you share to the community, like this can cause some challenge. So the first step will be, of course, about like publishing those plugins. We'll talk also a bit about how to extend the Gradle DSL in ways that play well with both the Kotlin and Groovy scripts and other JVM languages, and how to make your plugin work across Gradle versions. So publishing plugins, we'll make it quick. The idea is you can publish either to the Gradle plugin portal or an internal repository. But this is all well covered in the plugin development guides. But one thing to note is that publishing to a repository doesn't prevent the included build workflow we just saw, because you can use included build for build logic to, like when you are making changes to a plugin, but you have some tests. Of course you have some tests in your plugin code base.
Of course.
But you want to like test it like in a real build. So you take that build, you include your plugin, you declare the dependency, and then you can make changes in your IDE. You have both in context, and you can make change to your plugin, change to your Kotlin build scripts, see it reflected live, and so it provides a very good development feedback loop.
Yeah.
And this thing about, like you said, including builds, it's orthogonal to choosing monorepo architectures or multi-repo architectures. It's builds. The important boundary is builds. So we won't go into much more details.
So another important concern, right, as you write those plugins, is to make sure that, right, those plugins play well with the Gradle ecosystem, right, which is comprised of many different languages, right. Groovy, right, is historically the language, right, that has, it has like the start, right, it started all. So the amount of Groovy plugins out there, right, and you want to be able to reuse that. Also the build scripts, right, written in Groovy, you want to be able that you want to make sure, right, that your plugins work well with any build script out there, be it Groovy, be it Kotlin. And there's also the question of other plugins using your plugin, right? So plugins can also reuse plugins. So
like we did a Kotlin convention plugin that configures the Kotlin JVM plugin.
Right. And we could be writing a plugin in Java to configure a plugin written in Kotlin that configures a plugin written in Groovy, right? And we want to make sure this all works nicely together.
Or Clojure, or...
Yes. Or ETA.
Or ETA.
Yeah. So, yeah, there are diverse plugin implementation languages, so just keep that in mind, right? And I guess the important message is the common denominator across all those languages, right? Or it is that they all support some sort of static typing, right? So they can all call into statically defined, statically typed APIs, right? So it's much easier, right, to call, right? Or let's say it's always easier, right, to use statically typed APIs from dynamically typed languages than the other way around, right? So you should always prefer to actually put type constraints into your APIs.
So if you want to make it easy for people to use your plugin, make it statically typed.
Yeah.
Whatever is the language you use.
Yes. So some examples of that, right, would be, for instance, to always prefer exposing a statically typed API over unit-typed APIs. So for instance, instead of actually doing a single method that takes any or object, right? And behind, right, the things you're actually using as either a enum or some string, right? Provide both options, like these strongly typed options, right?
It will also provide a better IDE experience because people interacting with this API will see in the IDE that, oh, okay, it takes this type or this type, because object is like, okay, I can try
and then
to give it anything.
Can actually provide all the enums upfront for you to choose, for instance, in this example, right?
Yeah.
So the other thing you want to do, right, is to always prefer the Gradle model types, like the Gradle types or the Gradle API types over any language specific type when they are available, right? The most common example, and that happens a lot, right, is the action type, the type for configuration blocks or the type for actions, right, that act on a specific object. So the best way to do it, right, be it in a Groovy plugin, be in a Kotlin plugin, be in a Java plugin, right?
Yeah, here it's
is to use the Gradle Java. So this is a Java plugin API that is declaring some method, right, to use the action Gradle type. If this was a Kotlin API, right, this would be bad, even though it's typed, right? So okay, so it's a strongly typed API because we actually declare the actual type of my configuration object, right? I'm limiting the audience somehow, right? Now I'm forcing Java plugins to actually talk to this Kotlin API that, although might be simple to use, is not as usual, is not as like friendly.
Yeah, you would have to like import Kotlin types when you are in Java dealing with the Kotlin function.
Yeah.
But the Gradle action type will like unify all this.
And an extreme example, right, would be a Groovy plugin that decides to actually expose closures, which was
an untyped closure.
Yeah, so it's even an untyped closure. So we don't know, right? This closure can return anything. There are no annotations to tell me what actually it expects, right? So that makes it hard to use those plugins from statically typed languages, right? So that will be an important advice.
The last thing we will go over quickly about sharing plugin with a wider audience, being inside your company or outside to the community, is like when you have plugins like buildLogic in your build, you know what Gradle version is used thanks to the Gradle wrapper because it's like locked. But as soon as you start sharing your plugin across builds, they may use different Gradle versions. So there are just a few advices to make that not painful. So the first will be to always aim, if you have an existing plugin, like always aim for the latest Gradle version, supporting the latest. Or if you're start with the latest. So you can take advantage of all the goodness new Gradle release provide and apply the best practices because you like using the latest will make it easier. And then do cross-version testing. And that can be as simple as just a JUnit parameterized test. This is just a quick example. It's in Kotlin, but you should get the idea. If you look at the two arrows on the right, there is the list of Gradle version tested, and this is using the Gradle test kit that is a way to integration test Gradle plugins. And you set the version, and that's it. And then, with that in place, you can incrementally support Gradle version. Like you start with the latest, make it work, and then you add a Gradle version to the test matrix. You fix the grading Gradle section of the user manual will be very useful, going that like down version, and repeat. And you stop when satisfied, like, okay, I support this range of Gradle version, that's enough for my company, or that's enough for the community, or, okay, now I went back to 3.x Gradle, I'm overwhelmed, I just want to stop, it's good. And here is a small example using Kotlin to cross a 4.9 Gradle boundary where support for lazy task registration was done. Yeah, just an example. But that's like what we said about how to create DSLs that works well in statically typed DSLs like Kotlin, plus that it's the main two things to get plugins working in the most cases. So again, what did we learn? We saw how to create a Gradle build using the Gradle Kotlin DSL with or without having Gradle installed. We saw also how to customize this build with the Kotlin DSL, configuring extensions and tasks that are configured by the plugins you apply. Right. So the plugins block, the extensions like the application block, and tasks in the task block and with the type safe accessors and so on. We saw some mixing of Kotlin and Groovy build logic, which might be interesting for people migrating builds or dealing with existing build logic. We saw how to modularize a build into projects and how to organize your build logic by doing like pulling build logic up, doing cross configuration, further up into build source, and then further up into plugin you can share between builds and between organizations and to the community. And we talked a bit about how to author plugin that play well with different DSL languages and multiple Gradle versions. Yes. Here, some documentation links. You'll get the clickable versions when we'll send the slides to you. And that's it for
today, I guess.
For today. And so now we have a bit of time for questions.
I hope we do.
So is build source evaluated before the root script? Yes, that's correct. It's even evaluated before the setting script, meaning you could have in build source build logic that control the settings of your build. And you could, like, a regular Gradle plugin is a plugin of project, but you could also write a plugin of settings.
Right. Yeah.
Are the shown examples somewhere available? Yes, so we will provide you with all the example builds alongside the slides and the video. Good question. Can I use everything you showed today using Gradle 4.10? Unfortunately not.
Not everything.
Most of the
precompiled script plugin support.
Yeah, like the Gradle Kotlin DSL script inside Kotlin source set, they cannot be used. And 4.10, it also lack the type safe accessors for tasks.
Right.
Yeah. So it will be more work on your side, because you could still like go back to these referencing dynamic elements using, if it's only a name, using a string, and if it's name and type, you need the name in a string and the type.
Not available. So do we have Groovy DSL to Kotlin DSL converter? We don't have one yet. There are plans, but nothing concrete yet. We have some excited Java users here. Let's see. Can Gradle cache the configuration? That's a very interesting question, and it's one we hope to answer as soon as possible.
That's another interesting question. Do changes in the compile Kotlin task, as the one we did, like to change warnings to errors, also affect the Kotlin DSL script as well? And the answer is no. Why? Because when we change the compile Kotlin task configuration, we changed the configuration of the Kotlin compiler compiling your production code, not compiling the build logic. So do you think the Groovy and Kotlin DSL will live together, or will Kotlin replace Groovy as a new feature? So both DSLs are equally supported, and we have ongoing efforts to make progress on both, basically.
Yeah, so to go with that question, right, Josh asks, what are the limitations of the Kotlin DSL compared to Groovy at the moment, right? And what's on the roadmap for the Kotlin DSL? So I guess the main limitation, the one you run to, right, and we actually did run into this sample, right, is when you have scripts applied, right, to some project, right, in some context, and the types are simply not available, right, to the Kotlin script. So Groovy can do the dynamic dispatching magic, so types are irrelevant, right, or mostly irrelevant. But Kotlin cannot do that. Of course, the Kotlin DSL provides the with Groovy builder for the exact use case, but that's the main limitation, right? Is when you need to cross that boundary where types are no longer available, no longer visible. What's Gradle wrapper exactly, and when to use it? Would you like to answer that, Paul?
Sure. So the Gradle wrapper is a way to it's a bunch of files, like the mechanical parts. It's a bunch of files that you store alongside your source code. Like if you're using Git, you will put those files, the Gradle wrapper files, check it into source version control. And those files, they allow you to declare and lock what version of the build tool must be used to build that project. Like, for example, if I check out a project, or if I look at one of the projects I have on my shelf that I did 2 years ago, it was using Gradle 3.x. I just get the source and I use the wrapper, and it will download the exact Gradle version that is required to build that project, and it will just work. So it's like locking a Gradle version, and it's also providing a way to automatically download the Gradle version.
Mm-hmm. So how to access Gradle.properties in a Kotlin Gradle script?
So you can do that using the Kotlin DSL provides some shortcuts to do that, and it's Kotlin delegated properties. So if in your Gradle.properties file you have a property named foo with the value bar, you can, and you know it's a string, you can type var foo by project. And this will actually bring the foo, and you need to declare it, to declare a type. You need to say it's a string, and it will create a Kotlin reference to that property.
Oops. So basically like that.
Yes. Yes, exactly.
And if the property might not be there, you can declare.
If it's optional, like
declare it as a nullable type, and then it's optional, and then you have to actually check if it's there. So are there advantages to using Kotlin for build scripts over Groovy? I hope you should be able to answer that question by now, right? Or I hope
Yes,
we
like
were
the IDE support.
Yeah.
The IDE support is the main thing because like with the type safety of Kotlin and the IDE tooling, it means the IDE will help you a lot with source code navigation, refactorings, like compiler messages right as you type and so on. And of course, the fact that the language is statically typed means that you will get more feedback at compilation time and earlier.
Yeah.
With Groovy, which is dynamic, you will get like runtime errors.
Yeah. It's basically the choice between dynamic typing and static typing, right? And with the great IDE support, right, you get for Kotlin coming from JetBrains, right? So it is a good idea to add the deploy scripts to the Gradle. I'm not sure I get completely the question.
Me neither.
But if this is about like automating deploying apps, absolutely, right?
Yeah,
Like,
you should do that.
you should do that. So Gradle is built specifically for automation. What's the actual automated work you use it for, right? It's up to you. And you get all the benefits, right? Of like work avoidance and all that. And build cache. So I have trouble using the Kotlin DSL with an internal artifactory, Maven repository. Is there a way to pull in plugins from an internal repository instead of the plugin portal? Yes.
Yes, and I will say refer to the dependency management documentation.
Yeah, it's basically declaring, you know, where the plugins are coming from with the plugin management block in a settings script. But again, yeah, that's a good idea. Go to the dependency management fundamentals. It's pretty good.
Yeah, and like another question on dependency management. So please go to this other webinar our colleagues did from the dependency management team, Cedric and Luis. They use the Kotlin DSL in the webinar, and they show how to manage dependencies.
So can we use extension functions from Kotlin? You can use Kotlin extension functions, right? If you mean Groovy extension functions, because I recall Groovy also having some sort of extension functions.
It's coined extension modules. So yes, you can, and if you look at the Kotlin DSL primer documentation, there is explanations on how to call Kotlin extensions from Groovy and how to call Groovy extensions from Kotlin.
Awesome.
So any difference between by project and by extra? So by project is about referencing Gradle properties, like from the command line, or like Gradle project properties from the command line or from the Gradle properties file. And by extra is something else. By extra is extra properties. And you should look at the documentation for all properties that are available in Gradle is pretty neat. It's just a different bucket.
Yeah.
And the extra are dynamic and set by build logic, whereas the Gradle properties, they are set from the Gradle property file or the command line. So that's the boundary.
Yeah.
We could say Gradle properties come from the outside and extra property come from the inside of the build logic.
So another question here is there a way to reference variables for versions in the plugins block yet, or is that planned? So the plugins block is very limited, right? Like the API you can use there for a reason. You can use like static APIs from that, so you could use like system dot something, right? But it's not recommended. So is that planned? Yes, it is planned that we're gonna have a solution for global version management of plugins. It might not be exactly what you think it would be, like just reference variables, but yes, it's something that we very much would like to have soon.
Another one. What support is there for Kotlin script in Eclipse? For now, close to none. Like you can open the file and change it, but there's no IDE inside. You cannot refactor and all that. But like we said earlier, JetBrains, like the issue on working on the Gradle Kotlin DSL script support in Eclipse just went in progress. So it's moving. No ATA, sorry.
So another question about dependency management, again, I would refer to the webinar on dependency management fundamentals. It's really great. Is it best practice to use buildSrc instead of external Gradle scripts but lose the benefit from class loader separation? I think it's better to use buildSrc than scripts, also because of all the benefits Paul talked about earlier, right? You get to use the whole set of patterns we are used to with production code. You can have packages, you can segregate your dependencies across packages.
You can unit test your build logic.
You
can integration test your build logic. You can have things like check style or KT-lint or whatever.
Yeah, and the class loader separation is something that, right, it might eventually go away. So like if you really need the class loader separation, right, yes, so there's no choice. But I would say as a way to just organize build logic, absolutely.
Yeah, and it's a path to like sharing some build logic across builds. So it has also this benefit.
So Paul Sharp asks, what training resources do you recommend for migrating from Groovy to Kotlin?
So when it comes to Gradle, we have this migration guide. But it's specific to migrating Groovy builds, like Gradle builds written in Groovy to Gradle builds written in Kotlin. But there you will be able to find links to good resources on Kotlin. But I don't know of like a guide specific to moving from the Groovy language to the Kotlin language.
There are some like blog posts you find on Medium, right? But yeah, I haven't seen like the official guide or material, right? But yeah, refer to the migrating build logic from Groovy to Kotlin, and there are some tips there.
Mm-hmm. Yeah, and there are a few questions about having an automatic converter from Groovy to Kotlin, or an automated way in IDE to migrate. There's none for now.
So there's a question about how to import third-party plugins like Android into buildSrc. So basically that's by adding a dependency to buildSrc, right? But to add the dependency, you need to know the coordinates of the artifact. You can find the coordinates of the artifact in the plugin portal page of that plugin, right? And then if you refer to the page, you see both syntaxes. Mm-hmm. With like the plugin block and the build script block. Mm-hmm. The coordinates you want to use are those for the build script block, right? Mm-hmm. That's basically how you do it. Yeah. So Frederick Stats, asks, are there issues with plugins built on later versions of Gradle running on earlier versions? For example, the embedded Kotlin version.
There might be. For the embedded Kotlin version, the backwards compatibility characteristics of Kotlin apply. Yeah. So you should refer to, like on kotlinlang.org, there is this matrix of which component of Kotlin are compatible with according to the version and all that. And then I would say the best way to actually answer the question is to do cross-version testing. Mm-hmm. Like have a test and then make it run with Gradle versions, and then you see. And like if you are a plugin author, when we pull an RCO out, you just add that to your test matrix, run, and then you'll see if there is any trouble. Mm. Come back to us, we may have made a change we shouldn't have.
Yes, yeah. Especially things like introducing nullability into APIs, that's something that might happen. Yeah. And
Yeah, because Kotlin is strict. That's good.
Okay.
All right. Thank you all for your attendance and the questions and the thanks. So have a good one and see you soon.